Good morning. This is Wednesday's second lecture for this course, and I'm once again pre-recording this because I'm still at the conference in Mexico. I will return this Friday, and I will see you in person on next week's Monday lecture number 3. In the last lecture, we looked at how a number system is represented on a computer, and we saw basics of how a computer is put together, etc. And at the very end, I opened up MATLAB and showed you how MATLAB interacts with us. So every second lecture, for example, has a review of the first lecture. I will follow this pattern so that you recap what we saw in the previous lecture. As going through this list, we also saw what an ASCII table is and how various characters that we type from a keyboard are represented internally in a computer in a bit pattern, either in binary or hexadecimal, etc. So the table is reproduced in a more compact form for here with a 7-bit pattern up to 128 different symbols starting at 0. So you see the decimal, hexadecimal, octal, and then what the actual character is. Some of them are non-printable characters that mean something to the computer. But for us, I think we need to focus on things like the 32 decimal position, a space bar, an exclamation mark, all these symbols. So when you actually type these on the keyboard, the bit pattern that goes out to the processor is the binary version of this. In fact, this table doesn't list the binary version, but we will see how one can convert and translate from one basis to another basis. So in the next 4 or 5 lectures, we are going to be learning how to become proficient in MATLAB. So in the lecture notes, the PDF file, you will see some of the basic concepts that you should learn. And I will switch to the MATLAB to demonstrate how these things are used in practice. Okay. So the first thing that we need to learn is the definition of a variable in MATLAB. What is a variable and what are the limitations on constructing such variable names? Okay, so the first thing, for example, is that it must be alphanumeric, but the first letter must be an alphabet. Okay, and uppercase is different from lowercase. So MATLAB is case sensitive that you see here. And there is a maximum number of characters you can use to define a variable in a distinct way from other variables. And that turns out to be, I think, 63 or 64. But you don't have to remember it, but you need to remember that the name length max function will give you what is the maximum length is. So let's just start MATLAB and start playing with these things. Once again, I hope I'm logged in. I am connected. So I'm recording this from home. I'm flying out tomorrow morning, and once the recording is completed, I will upload it tomorrow. So we already saw how to start MATLAB in the last lecture, so I'm just beginning from that point on. It seems to take some time to check out the license. Yeah, there it is. So I have a license checked out, and you would do in your lab, you would also have to check out the license, but it will be transparent to you. But when you're doing it from home, if you have the MATLAB on your own PC or Mac with your own license, then it will be transparent. There's nothing to worry about. But if you're accessing the LSU VLab or some stuff, you need to authenticate yourself as a legitimate user of the LSU resources. That is, as a student using LSU ID and password. And this will be demonstrated in one of the labs. Now, as I saw in the last class, this is the window that you get, and it is organized into sub-windows. So the whole MATLAB window is an application window. So you can move this around, and inside that you see there is the current path that is displayed here, and the current folder, and into that folder you have number of functions, and you can pull down and go back to historically what other folders you have used and switch to one of them. So L01, this was the folder that we used last time, but I want to go to L02 for the current lecture. So these are the files in that folder, and I have one MATLAB related file there. And the third part is the workspace that we saw. Now we are trying to learn how to construct variables. Okay, so a variable is any symbol that you give, a name that you give, starting with an alphabet and then following it by any number or any underscore. Anything like this would be legitimate, and then you will have an equal sign that says that variable is assigned a particular value. The value, let's say, is 546. Okay, so I have a variable named a123 underscore a, and it has a value of 546. It is in the class of a double. That you should know from what last lecture. A double is one that has 64 bits to represent that number internally. The size is 1 by 1. That simply says that it is a scalar array. And the byte is the total length, 8 bytes. And each byte is 8 bits. So 8 times 8 gives you the 64 bits to represent this number. Okay. Now, if I want to create another variable, a123a underscore a, that would be a different variable. Why? Because it is case sensitive. Here I use lowercase, here I used uppercase. Okay. Now that would be different from a1 is equal to 235, for example. Now this is just a variable called a, but it has an array structure. Okay, so it creates a third variable a, and it still is only 1 by 1. Okay, now MATLAB allows you to construct larger arrays, and we will see that soon, but let's use this function, name length max, okay, to understand what it does. So I just copied it to my keyboard and I type it here, and it says 63. So the maximum length of the variable name that you give can only be 63, but it can consist of a mix of characters, alphabets and numbers, uppercase and lowercase alphabets, and underscores, a few other limited operations. There are certain characters that are reserved. You cannot use them in constructing the name. So this is how you create a variable in MATLAB, and whenever you create a variable and assign it a value by putting an equal sign and a number on the other side, you will have that value recorded. So I can do, for example, b is equal to a times a123a. So what this does is that it looks on the right hand side of equal sign, it looks for a symbol a and says, well, is this defined? I'll go and look in the workspace. Yeah, it is defined, it has a value. So we'll substitute the value here. The star means it's a multiplication operator in MATLAB. And so then what follows is another symbol. So it checks whether that symbol is a name. If it finds it in the workspace, it's a name, so it has a value, and it will substitute the value and carry out the operation, and then it will assign it to b. So this process is called parsing. It parses what you type, tries to make sense of what you mean, and carry out the execution of that instruction and returns the value. In this case, it's going to take the product of 235 times 345 and store it in a new variable called b. And that variable also inherits the class, because both on the right hand side were double. This is also double, meaning it's a double precision number, and it is also just a character 1 by 1 and 8 byte long. Okay, but I have let's look at array. I showed you how I can do a1 equals something. Okay, now can I do this? A equals 124 space 234 space 345. So this is how I would create a variable called a and assign it a vector value. more than one value. It's called an array or a vector. Now, I'm saying take these three numbers 1, 2, 4, 2, 3, 4, and 3, 4, 5, put it into a vector variable called a. But then I already had a variable defined before. So what happens? When I do this, it overwrites, it forgets what was there in the previous definition of the variable, and it replaces it with the current definition. And it shows that the variable is 1 by 3. Because there are 3 variables, each one is 8 bytes. So it occupies in the memory a space of 24 bytes. And the actual decimal value is this. Okay, now you can carry out operations between a vector and a scalar. So for example, you want to say C is equal to B times A. Okay, now again the same idea. So it looks for B. B is 81075. It's a scalar, and A has actually 3 numbers. Okay, so then MATLAB says, what do I do? What is the meaning of the star here? And MATLAB assigns these definitions and meanings, and this is what we are trying to learn. Just like learning any new language, natural language, if you're learning Chinese, Mandarin, or Korean, or whatever it is, you need to learn the way that they represent the concepts. If you're interested only in communicating orally, verbally, then you need to hear the sounds and what do these sound patterns mean. If you're learning to read and write, you need to know what these characters are, and combination of characters are words, and these words have meanings. And because the human beings share similar experiences, we have similar concepts, similar emotions, but the way that we express them in terms of language is very different. And the same idea with computers. Okay, so we are learning what we call the syntax of a particular language. The syntax for C may be different from MATLAB, may be different from Java, etc. Okay, so here it produces a vector, and the vector is assigned to C, and it is a product of each one of these numbers with B. Whatever B was, it multiplies by A1, A2, A3, etc. Now, can I just access the second variable in A? And the way to access or address a particular element in an array is put parentheses following the variable name, and then just enter that particular number. Okay, so you're getting the second variable stored in A. Now, if I type A2, what happens? A2 does not address the second element of A. A2 is a variable name by itself. And if I hit enter, it will say undefined function or variable. So when I type something like this, it actually first checks the workspace to see whether it's a variable. If not, it actually checks a detailed path, searches the path to find if there is a function, and we will see what a function is later on by that name. And if it is either a variable, neither a variable nor a function, it says I give up. It's undefined. I don't know what to do with it, or I don't know what you are asking for A2. So A2 is, this type of A2 is different from A subscript 2. So subscripts are always provided within parentheses. Okay. So let's go back to the notes. I don't want to deviate too much from the notes. So we saw basically how to create variable names, some of the restrictions on the variable names, etc. Now I started playing with arithmetic operation as well. And one of the best ways to learn a language, computer language or any natural language, is practice, practice, and practice, right? So you need to go on to MATLAB this evening and start playing with it from the lecture notes. I'm not going to be able to cover everything that I have put on this lecture notes. There are about 16 pages, but these are all just illustrations of various ways of interacting with the command. So read them and play with them and make sure that you understand in your mind what each of the syntax operations mean. Now, there are a number of other variable names. We saw already name length max. If you enter, it has a specific meaning. You cannot assign name length max equals 5. Well, you can, but if you do, then the meaning assigned, pre-assigned by MATLAB will be lost. Maybe let's try that. Okay, so we tried, one of the tricks is you can recall previous commands you entered with the up arrow. I'm just pressing the up arrow. Okay, so when I just enter this, it gives me 64. But if I do 76, I'm assigning the same variable name a new number, and it becomes 76, right? And then if I say print that, it gives 76. That would be the wrong interpretation because you have changed the meaning of something that was built in. If MATLAB was smart, it shouldn't have allowed you to change it, because you should have said it is a reserved name or function. You cannot use it, but MATLAB doesn't do that. Okay, so the onus is on you to make sure that you don't redefine already defined meanings in MATLAB. So if you want to clear this function name, all you have to do is type clear that variable name length max. Okay, then it goes away. And now if you type name length max, again I'm just going to recall, it will reset the original value that MATLAB has predefined. Okay, this is something that's not in the notes, but you learn by putting together what we have learned in different ways and playing with it. Now there are a number of other functions that are available that are named whose, clear. I already showed you clear. You can say clear variable name 1, variable name 2, etc. to clear out as many variables. If you clear without any particular variable specification, it clears out all the variables in your workspace. And let's go back and look at what who and who's do. Okay, what does who do? So it says your variables are A, 1, 2, 3, C, etc. So it lists all the variables in the workspace. Whose gives you more details. Who just gives you the name, variable name you have defined. Whose gives you what is its size, what is its class, how many bytes does it take, etc. Okay, a variable has a number of different attributes, and it gives you all the attributes. We saw in the previous class that you can create variables with different class attributes: single, double, character, integer 4, integer 8, integer 16, integer 32, etc. There are a large number of such functions that are available in MATLAB. So let's just explore a few of them. I'm just keeping track of time. 17 minutes. I want to record for about an hour, and with the idea that Jillian will pause at times when you have questions. Just raise your hands and ask for questions, and hopefully you can clarify them by demonstrating. Okay. So let's my apologies for the interruption. There was an alarm that went off at 4 a.m. I need to go and turn it off. Let me continue recording. So we were talking about the commands that allow you to examine the variable name, and now we're going to explore a few commands to assign different classes of variable names and convert from one to the other. Okay, and then we'll go back to array structure, addressing arrays, etc. So I'm not going to be able to go in detail discussing every function, all its features. Okay, so when you see a function listed in the lecture notes, you become responsible for knowing how to use it, what it does, what it produces by playing with it. I'm just going to show you, open the door for you in some sense, and show you what it can do. I hope it's recording. All right. So decimal to binary. Let's first look at single, double, character, etc. What do they mean? Okay. So if I want to define a variable by default, if I define a variable, let me just clear all of them first. So you see how the clear function works. It wipes out everything from the workspace. This is just a display window. So the fact that it listed is a consequence of my previous command. If I write who's now, it'll pull out the variables from the current workspace, which is nothing. Okay, so if I by default, when I assign a variable like a equals 445, it assigns it as a double variable. But if I say a is equal to single 45, then this is called a function. Single is a function name, and functions takes inputs and produces outputs. Okay, so this function single takes a decimal representation 45 and stores it in a capital A as a variable name, assigning it a value of the same 45. So the lowercase a has 45, the uppercase a has 45, The lowercase a is a double class, meaning it is using 64 bits, and the uppercase a is a single class. It means it's using only 32 bits, that is 4 bytes. Okay, so it occupies less memory in the computer workspace. Can I do arithmetic operations between them? Let's try this. C is equal to a times a. So it did produce the product of 45 times 45, which produces 2025, but it assigns by default a class type of single. Okay, because on the right hand side I had a mixed class, a double and a single. You can do it under certain circumstances and you cannot, because when it doesn't make sense to mix classes of different attributes, then that operation star is not defined. Here they both belong to decimal space, 45 and 45, and so it knows how to carry out the multiplication, but it assigns the variable to a single class. Okay, and then we had character, integer 4, etc. So let's make an integer 4 variable. A is equal to int 4 45. Did I mean int 64? No, maybe that int 8. I guess int 4 doesn't exist, so I should fix that in the notes. The lowest one you have is only 8 bits, integer 8. Okay, so it's the same number 45, but it is represented as an integer and it is overwriting the variable name a. Okay, now it is int 8. Okay, so with int 8 bits we already saw that the largest number that we can represent is only 255, right? So if I produce a number that is bigger than 255, if I use int 8 as the basis, it will not be able to produce. For example, if I say 45 times 45 and I assign it to, say, variable c, what do you think it will produce? Now, one way of learning as you are playing with this is don't blindly enter what I'm giving you, even in worksheets in the lab, and then you can finish all it in 10 minutes and say, okay, I'm done, I'm leaving. You would not have learned iota. Okay, what you need to be able to do is think about each command and predict what it will do. It's wrong. If it is wrong, that is absolutely fine. Okay, because that's a learning opportunity for you. Then you can ask, why did I do this? Why is it wrong? Why is my thinking not in line with MATLAB's thinking, or other people that wrote MATLAB think? Okay, so if I say 45 times 45, it produces 2025. And it's the same number as I got before, and 2025 can be represented, I guess, in double. Okay, so, oh, I'm sorry, this is just 45 by 45. 45 is a double by itself, so it produces 45 times 45. What I really wanted to do was integer 8, which is c is equal to 8 times 8. Okay, now a is a variable belonging to integer 8 class, which can represent only the maximum number of 255. Let's before we do this, let's try that. So if I say b is equal to integer 8 4056, what do you think it will do? Once again, predict, knowing already what you know about int 8. Okay, int 8 can represent only 127. And there is a reason for it, and we'll come and explore that later on. So when I enter a number larger than that, it cannot represent using 8 bits. So the maximum number it can represent is only 127. So it says, okay, I am going to truncate it to 127. This is a source of error in any arithmetic operation in any computer system, and you need to be aware of such sources of errors. The finite precision that you can use in a computer introduces certain ranges of numbers that you can represent, and if you're doing arithmetic with numbers larger than that, it is going to introduce serious errors into your calculation. Okay, you might say, why do I need to use integer 8 or integer 16 or integer 32? The reason is you want to conserve memory, and when you write large programs, memory becomes an important issue. Memory management becomes an important issue. Okay, so you can click on int 8 to learn what it does whenever it produces a highlight. So it says it's a function, and it convert to 8-bit signed integer. Okay, every word makes sense here, right? Signed integer. So when you have a signed integer, there is 1 bit that is reserved for the sign, whether it's plus or minus. That's 2 states, right? So that only leaves 7 bits to represent the actual number. With 7 bits, the maximum number that you can represent is only 127. And that's the reason why it truncated it to 127. Now, there is another function, let's close this, called unsigned integer. So let me recall this and try uint. Okay. Now, at this stage, I'm introducing some functions that you haven't heard of. So you might ask a very legitimate question: how do I know that such a function exists? Okay, that comes from reading and playing with MATLAB and learning. Learning is learning new things that you don't know already, right? So obviously you need to spend time to learn these things. When I tried this uint, that means it can represent, as I said, with 8 bits, the largest number, but you cannot represent a negative number with this function uint8. Okay, it can represent only numbers going from 0 to 255, whereas the int function can represent negative numbers. For example, if you go here and then say minus 45, it'll assign it as minus 45. So if I go and assign uint minus 45, it cannot. The lowest number it can represent is only 0. So it converts that into 0. Okay. So obviously, as I said, I cannot, one can play on this ad infinitum, and I want to cover more material. So I have opened this door for you to play with these variables that these functions that you have. Okay. And in any one of those functions that you find in the notes, you are responsible to know how it works. And one way of learning that is just type help uint8, for example. Help, the name of the function, and it will print you the information about that particular function in fairly detailed length, and then it will give you some related functions. Okay, and by clicking on any one of them, you actually will see a nicely formatted output window that will open. I think I'm getting interrupted by some of the push notification. Let me just recover and see whether I can. Because it doesn't open up the help window. Normally it should. When it is highlighted with a hyperlink and you see the sign like this, you can open up a help. Yeah, and that's nicely formatted. And here you can once again search for certain functions, and there's a search bar here, and there are 10,000 functions or so, and we are not going to be able to cover even 200 or 300 in this course, but that tells you how to learn on your own. Okay, and that is what is most important for you to achieve in this course. Okay, so the next one is how to do the conversion from one class to another class, from decimal to binary, from double to single, etc. Are there functions available? And the answer is yes, and here are some examples. So I guess I didn't talk about character, so let's see, how do I assign a character variable? So if I say variable a is equal to, okay, if I put within strings, then it becomes a character variable. Okay, and you see the class as character, its size is 12, and its length is 24 bytes. Okay, and it is just a string of, it is not a number. Okay, it's just a string of variable's name. And the same thing would happen if I say 1, 2, 3, 4, 5. Okay, this is not a number. If I put within quotation marks, it treats it as a character. Now this becomes 1 by 5 character. So if I want to address the 4th character, I can say A4, and it will give me the number. Right? So to address a particular element of an array, we just put the array position in parentheses. This applies to both numbers and characters. Okay, obviously you cannot mix a character with a number. You cannot do operations like 1, 2, 3, 4 times 4. I'm not sure what it's going to do, because I'm saying take the product of 4 with a string with characters. I guess it did something. We need to understand what it exactly did, and that may actually lead us to the ASCII table, because number 1 has a representation in the ASCII table that we saw. Okay, so it's perhaps taking that, like 49, right? Number 1 has a decimal value of 49. So maybe, I'm just guessing here, it's taking 49, exactly 49, and multiplied by 4. Then 50 multiplied by 4, 51 multiplied by 4. Okay, so when you do a character, it has an interpretation. Okay, I'm going to take from the ASCII table whatever the number is. Now, if that is true, a curious mind would say, what would it do if I say ABC times 4? Again, to us, in regular arithmetic, it wouldn't make sense. But MATLAB does exactly the same thing. So you go and look at what A is in terms of its 65th decimal place in A. Okay, and when I give a lecture like this, I just spontaneously think about problems. This is why every lecture would be different. If you listen to lectures from previous years, it's just on the same topic, but the examples that I use to demonstrate a particular concept might be different. So you have access to the past 2 or 3 recorded lectures as well from Moodle, particularly on MATLAB. Okay, so we know now what a character variable is, and I just learned that you can do multiplication between character variables and numbers, but it takes the ASCII table interpretation of it. So let's go back and look at D, C to BI, and D. Now, to a stranger, this would make no sense. Why would you name a function like this? But you can give an abstract name like John, right? But you won't know. So the naming is done in such a way that gives you a hint as to what it might be doing. So here this function converts from decimal to binary. Okay, so it expects a decimal number as an input. Any function will expect certain inputs, implements certain rules, and produces certain output. So here D is the input, the function name, which contains the rules, which is coded, the rules are coded in there, and we will learn how to write functions by ourselves. And its goal, its purpose is to take a decimal number and produce a binary version of it, decimal to bin. So let's go and play with it. Okay, so A is equal to DC to bin. I want to pass a decimal number. Now you would notice when I type like this, I guess this time I lost it, but as you are typing it, I guess bin, it tells me what are the inputs that I can enter, D, and I can enter D and M. If you want for more help, you can ask for more help on that. Okay, so it tells you that what it produces is a string, what it accepts is a decimal number, and I'm not even sure what N is. And that's another thing that you need to know. MATLAB, you cannot know all the 10,000 functions. I'm not using this language on a day-to-day basis, so it's important for you to be able to find what a particular function does on the spot using these help features, and they will tell you what N is. So it produces a binary representation with at least N bits. Okay, so N stands for how many bits you want to use to represent that. Okay, now we understand, we already understood what a bit is and what a bit pattern is. So let's play with it and see whether we can learn. Okay, so if I say 65, what is the bit pattern for 65? You can verify this. It says 1 times 2 to the 0 plus 1 times 1, 2, 3, 4, 5, 6 to the 5, or 2 to the 6. Okay, so you can actually verify this. 2 to the 6 plus 2 to the 0. Okay, because in the 0th position I have the base 0, I have 1, everything else is multiplied by 0, and in the 7th position I have base 1. So if I enter this, I should get 65. Okay, so this is, and I want to explore now the second argument. So it said instead of doing it in 7 bits, I say do it in 10 bits. So all it does is adds 0 to the left. Adding 0 to the left doesn't add any additional value, right? So this is the bit pattern for 65 in a 10-bit representation. How does it look in a 32-bit representation? That's how it looks in a 32-bit representation. And how does it look in a 64-bit representation? I think you get the idea. But what MATLAB does is always uses the 64-bit representation, okay, for double precision. Actually, that's not true for integers. This pattern would be exactly true, but for floating points, the 64 bits have a particular meaning depending on the bit position, which we saw in the previous lecture. There is a mantissa part, there is an exponent part, etc. So the decimal to binary function essentially converts a decimal number to binary in any number of bits. Okay, and similarly there is a function, inverse function called bin to decimal. Okay, what does that do? Bin to decimal, as you would expect, converts the binary representation to a decimal. So you can say, since it's binary, it has to be represented in a character form. If you put 0, 1, 1, it will take it as a decimal representation and it might give you an error. Okay, so if I do 1, 0, 0, 0, 1. So take this as a bit pattern, not a decimal number, a bit pattern. In decimal number, this will be probably 1,000,001, or no, not 1,000,001. 1, 2, 3, 4, 5, 6, 7, 1,000,001 or something like that, right? So this is a bit pattern I want to do. So it gives me the correct answer, which is 65. This bit pattern in decimal world represents number 65. Now, normally as chemical engineers, we don't deal with the bit representation as much unless you are a process control engineer and dealing with the interfaces between computers and data acquisition systems. Then you will be transferring these bits from your thermocouple or pressure transducer to your computer. You need to worry about and understand these things. In other realms of chemical engineering, we don't. But in process simulation, there are certain situations where you will deal with floating point numbers that are too large or too small, and you need to understand the concept of what a particular class is and what is the maximum and minimum number that you can represent. Okay, so there are functions like real min, real max. Okay, so that will tell you what is the maximum number you can represent. So let's go back and try real min single. So what the real min function gives you is what is the lowest number that you can represent in single precision. Okay, 10 to the minus 38. So if you do, for example, single 4 times 10e minus 50, okay, minus. So what I'm saying is assign this number 4 times 10 to the minus 50 to a single precision variable, and it says I cannot. It is, so it truncates it to 0. Okay, but if I had done this 28, that would be representable. So it will actually assign that value. Of course, floating point, it shifts it by 1, so it is 4 times 10 to the minus 27. The lesson we learn from this is each class has a particular range of numbers that it can represent, and you can access them easily in MATLAB by using these functions called real min, real max, and passing a variable to it. So if I had done real min double, it gives you the smallest number I can represent now is not 10 to the minus 37 or 38, but minus 300, because I have more bit patterns for the exponent part. But for the mantissa part, it is always about 16 significant digits. In 16, it only shows you the 4 significant digits by default. If you do format long, set that it's a switch. When you flip it and then you enter real min double, it will give you all the 16 digits that you can accurately keep track of. Okay. So perhaps at any time feel free to stop, put up your hand, and Jillian will pause and come and answer your questions. I want you to continue to explore these decimal to base, base to decimal, hexadecimal to decimal, decimal to hexadecimal, etc. on your own. In quizzes, in exams, you will have all the functions that appear in the lecture notes that I distribute in the functions that we use. So you should be able to understand what they do and what they will produce. This is the most powerful function, in fact, decimal to base, because the base can be anything and you represent the base with b as a second input parameter. Okay, so the first parameter is the decimal number, the second parameter is the base. Maybe that's important for us to illustrate. Okay, decimal to base, I guess. What does it do? Decimal to base. So some decimal number, okay, say 546. And what is the base? If the base is 2, then it converts to binary. You get the typical bit pattern that you will get from decimal to bin. But decimal to bin only gives you always binary. This one can give you octal, 8 bits. 8 as the basis, 0 to 7. Okay, then the octal representation of 546. 546 is the decimal representation. The binary representation is this. The octal representation is this. Okay. If somebody tells you that I want to represent number 1097 in octal, immediately you should say that's not possible, because 9 cannot appear in an octal representation. In a binary representation, only 0, 1 can appear. In a decimal representation, 0 to 9. And in an octal, 0 to 7. And in hexadecimal, 0 to 9 and A, B, C, D, E, F. Okay, so if I say do this in hexadecimal, it is 222, right? One thing you notice, the smaller the base, the more characters you need to represent. Okay, so in a decimal base, we needed 2, 4, 6, 8, 10 positions. In binary base. In octal base, I needed only 4. In hexadecimal, I needed only 3 to represent the same number, 546. Okay, so that gives you how we manipulate things in MATLAB, the concepts that we have learned about classes and bases, etc. Let's go and spend some time on array structures and array addressing. Okay, a few more comments. Anything that appears, if a percent sign appears in your line, it is treated by MATLAB as a comment. Anything to the right, it simply ignores. For example, if I have enter A equals square brackets 1, 2, 3 semicolon 4, 5, 6 close brackets, and then I put a percent, the semicolon starts a new row. So I'm trying to explain to you what the semicolon does here. Okay, and so you can put any comments like this in MATLAB in the same line or in a line by itself, etc. But it is a comment. And MATLAB prompts are given by this. We already know variable names are case sensitive. We already know, and the variable name has to start with a character, an alphabet. So it cannot be tall A is not a valid variable name. Okay, so here I have assigned a variable A as 1, 2, 3 semicolon 4, 5, 6. So I explained that this starts a new row. So actually what I'm defining is a matrix A. In the first row it has numbers 1, 2, 3. Second row it has numbers 4, 5, 6. And if I say who's A, it tells me that A is a 2 by 3 matrix, 2 rows and 3 columns. 2 rows and 3 columns. And it takes a total storage of 48 bytes. There are 6 variables that are 6 numbers that are stored and belonging to the class double. Okay, you can also enter an array by entering A equals 1, 2, 3 and then hit enter and continue to enter 4, 5, 6. Hit enter. So it creates, each enter is treated equal to a semicolon. So it starts a next row. Okay, and that produces a 3 by 3 matrix. Okay, so you should continue to read what is in the notes, but I'm going to switch to MATLAB and illustrate some of these things in a spontaneous ad hoc manner. And if there are questions, you put up your hand, and normally I will respond to that, but in this lecture, Jillian should be able to help you with that. Okay, so let's continue. Let's clear the workspace. Okay, everything is wiped clear. And I think you can also clear the screen, CLC. That's another command that clears all the screen, but you still have the history. Okay, so if you press the up arrow, all the commands that you have entered in the past will still be available for you to recall and edit and resubmit. Okay, so let's construct some matrices and vectors and make some mistakes and learn what is allowed and what is not allowed. So if I say A is equal to 1, 2, 3, as I said, semicolon 4, 5, 6, semicolon 6, 7, 8, something like this. I'm just making a 3 by 3, and you can continue this. I can make a 4 by 3, 4, 5, 6, for example. Okay, so this will have 4 rows and 3 columns. Now, if I'm interested in addressing this particular number in some calculation, how would I do that? So I need to tell MATLAB. So the square brackets is one that defines what a matrix is and assigns it to a variable through the equal sign. Now A is already defined as a 4 by 3, but I want to address the second row, second column. The way to pull only that number would be simply A2, 2. What does a 2, 2 mean? Second row, second column. It prints only that. If I say 3, 2, it'll print number 7. Now, when you do this, you need to be able to predict and say, okay, now what is it going to do? It does what you're expecting it, right? Now, if I want to address the second and the third numbers from the second row, can I do that? And this is called array addressing. Array addressing always starts with a variable name with a parenthesis. And the parenthesis, if it's a two-dimensional array, a matrix, you should separate them by a comma. Okay, so you can say 2, comma, and then you need to say second column and the third column. So you need to define another vector inside. So you can say 2, 2 space 3 and close that. So make sure that you understand, because we are now covering very quickly more advanced features. Okay, so always array addressing has a comma, and the first set represents the number of rows. The second set represents the column range, the row range and the column range. So you can pull a subset of the matrix from the matrix A through this array addressing. Okay, so if you enter, you should predict in your mind what you will get. Okay, the second row, second and third column, you should get 5 and 6. Oops, 5 and 6. Right, and you can assign this, of course, you know that, to any other variable. So by this you are creating a 1 by 2 variable C. C is a 1 by 2 variable. It contains number 5 and 6. A contains lots of numbers, so it doesn't display what it is. But if you double click on that, it will open up another window for you. And this is an array window, and it actually shows the array in the Excel spreadsheet type of format. Okay, and you can close this to get back to your previous default setting. So once again, let me display A, and then D is equal to A. I want to pull the second and the fourth rows. So I would say 2, 4, or 2 space 4, comma. Now you can put a comma here. Okay, or you can leave it as a space. Either one, meaning is the same. I'm saying second row and fourth row, and I want to take the first one and the third one. This is perfectly legitimate and allowed. But what it's going to do is produce a 2 by 2 matrix, pulling elements from the 4 by 3 matrix. Right? So you need to be able to predict what the matrix D will look like. And what I predict would be 4, 4, and 6, 6. Why 4, 4? Because the second row and the fourth row, and the first column, that's 4, 4, and the third column, 6, 6. Okay, for 4 and 6x. So when you do that and you get the same thing in your mind, you understand how array addressing works. Okay. Now, if I want to pull all the elements in a particular row or a column, how would I do that? For example, I can say D equals, I want all the numbers in the third column and then in the first column. Okay, so I'm saying all the numbers. So the way to say that is just colon and then 3, 1. So I'm saying take the colon indicates, without colon is an operator. Everything in MATLAB is kind of an operator, right? We'll see what a colon operator does in greater detail soon. But colon without anything says take all the numbers in that row position, right? So that is 3, 6, 8, 6, because I'm addressing third first, right? So take these numbers 3, 6, 8, 6, and then take the numbers 1, 4, 6, 4 and print them out and assign it to D. So you'll see that, let me open up. Not sure whether you can see both of them. 3, 6, 8, 6, 1, 4, 6, 4. And that is how you address arrays. Now, the colon operator is an interesting one. So it essentially has the following syntax. You can say 1 colon 3. Okay, what it does is produces a number from 1 to 3 in steps of 1 by default. It will produce 1, 2, 3. So if you say 1 to 10, it will produce 1 to 10. Now, if you say 1 colon 0.1 colon 2, okay, then it goes from 1 to 2 in steps of 0.1. Okay, so then it automatically produces a double precision 1, 1.1, 1.2, 1.3. Okay, so the syntax of the colon operator is very important for you to understand. So you can say help colon, and it tells you what the colon operator does and how you can use it. J colon K is the same as J, J plus 1, J plus M. Okay, and it explains in detail, and you are responsible for learning those things by yourself. We will demonstrate it in the class, and I think that should give you an idea on how to get started. And then if you play with it, you will learn. So for example, can I do this? 4 colon minus 1 colon 1. Minus 1 I said. What do you think it will do? Okay, so I'm saying start from 4, go in steps of minus 1 to 1. So it's going to produce 4, 3, 2, 1. Can I do this? 4, start at 4, go in steps of 1, minus 1, go to minus 1. What would it predict? What would you predict? It's 4, 3, 2, 1, 0, minus 1. Okay, and that's what it does. So you can flip the direction in which you construct. Then the question comes, what would happen if I put this? 4, go in the direction of -1 to 8. It cannot do that. It starts at 4 and then it says 3, 2, it will never reach 8. So it will then say it's a null matrix. It's empty. It has nothing in it, right? I think that gives you an idea of what the colon operator does. And we have another 6-7 minutes. Let me see. Addressing specific elements. We saw assigning specific elements. That's another interesting part we need to learn. Okay. So we saw that in general we assign a variable by simply putting a equals and then construct some matrix, right? 4, 6, 2, semicolon, 2, 5, 7. Oh, here is another one that you should do. If I did this, what do you think it will produce? I'm saying A is equal to 5, 6, 2. That means there are 3 columns. And then start at next row, and then I'm giving 4 columns. That's inconsistent. So MATLAB should produce an error message. Dimensions of matrices being concatenated are not consistent. Now, the error message it gives you is often very cryptic, and you have to get used to interpreting it. So what the semicolon operator is called is a concatenation operator. Okay, so it concatenates 2 arrays into 1 array. And for that to happen, you should have the dimensions being consistent. You cannot have 3 columns in one and 4 columns in the other and say, combine these two. MATLAB wouldn't know what to do with it. Okay, so what you really need to do is be consistent. Now, what I wanted to show you is if I want to replace this number 4 only, keep everything else the same, right? How would I do that? This is the assignment, so selective assignment. So you would say, take the second row, second column, and it has 4 currently, but I want to replace it with 16. Okay, everything else being the same. Now, from what you have learned, if you are good at computers, you will be able to predict what this would do. 2:3, 16:32. What do you think it should do, right? Currently, A is 562 in the first row, 216.6 in the second row, and I'm saying take the second row and take the second and third columns. That means 16 and 6, and replace them by 16 and 32. So it's selectively in a subgroup of matrices you are replacing the value, leaving everything else the same. So what you're learning is the first few basic steps and how to use them more and more creatively to achieve a number of things that you want to achieve. Eventually what we want to achieve in this course is to learn to solve chemical engineering problems. But if you're going to use MATLAB, you should be able to converse with it in a very proficient, natural manner. Okay, so that is what the first third of the course is about. As I told you, the course is done in 3 stages. First stage MATLAB, second stage is model building, third stage is algorithms. In the model building stage, we will learn how to solve those problems using MATLAB based on different categories of models. Okay, I'm going to go and take a look at the notes and what else do we have that I haven't covered. Address a group of elements, I just showed you that. Assignment of a group of elements. Extraction of a group of elements. The size function. Okay, the size function is a built-in function that just gives you the size. It's like but size can be useful when you're writing functions to extract information. It just says what is the size. It's 2 by 3 matrix. Okay, there is another function called length. So for example, I say v is equal to 1:0.1:100. What I've done here is 0.1. What I've done here is created a vector b starting at 1 going to 100 in small steps, 0.1. So it's going to be a huge vector, right? And I didn't want to print it out, so I put a semicolon at the end. So another thing that you need to recognize is the meaning of the operator changes depending on the context in which it is used. Semicolon in defining a matrix starts a new row. Semicolon at the end of a line says suppress the output. So it will not produce any output. Typically when you enter something, it produces an output immediately. This time I've deliberately suppressed it, but it did create the vector b with 991 elements. So it's a vector, it's a huge vector. Now if you created something like this and you wanted to find what is the length of the vector, there's a function called length, and pass the variable name to it, and it says there are 991 elements. Now you can say, well, it shows me in the workspace, why do I need to use the length function? The workspace is not kind of available visibly to you when you're writing a program, your own program. So the length function will be able to query what is the length of a particular vector, which you can use then in the function itself. So you will appreciate that later on when you're beginning to learn how to write functions by yourself. Okay, and so we covered size. There are lots of exercises here, concatenation, etc. You should play with it. Yeah, concatenation of 2 matrices. That's probably worth exploring. Okay, so I'm going to clear the workspace once again. I'm going to define A as 1, 2, 3. Sorry. If you do 12, it's just a number 12. If I say 1 space 2, it is first column 1, second column 2. Okay, and then 3, 2, 1. Created a variable A. And then I'm going to create a variable B. It's an array, but this time it's going to be 3, 2, 1, 1, 2, 3. Okay, so if I want to produce a matrix C, which is a combination of A and B with B below A, how would I do that? Or B besides A, how would I do that? This is again using concatenation operator. Okay, so if I say C is equal to A semicolon B, Semicolon, remember, puts the rows below, next row below. So it will take A and then try to put B below that. But for this, the dimensions must be consistent. If I have 3 columns in A, I must have 3 columns in B. If not, the concatenation operator won't work. So here you have combined C, but placing B below A. What would happen if you did this? A comma is a concatenation in the horizontal direction. So again, the dimension must be consistent, and this is your A, and that is your B. They are placed horizontally. Now, as I said, the comma is also represented by space, so that will also work. Okay, so that is about the concatenation of arrays, and this just demonstrates inconsistent request for concatenation. Why did we learn all this? Let's see whether we can apply this to solving a problem from linear algebra. Okay, suppose you are given 3 equations. This you would have seen in 2171, and you would have seen in math course as well. In 2171, when you write equations for mass and energy balance, you might end up sometimes with a set of linear equations that you need to solve. And you would have done it probably by hand elimination and in Aspen perhaps. Aspen solves these sets of equations, and what we want to do in this course is learn how Aspen solves these sets of equations. So if I'm given these 3 equations and these 3 unknowns x, y, z, okay, and I want to find what x, y, z is. So how do I do that? I define a matrix A with elements 3, 7, minus 8, 6, 1, 3, and minus 1, 4, and 2. And I multiply this by a vector x. And the vector x consists of the lowercase x, y, and z. When I do this matrix multiplication, I will get the left-hand side of this equation. I want this to be equal to the right-hand side, so I create another vector b. Okay, so and then I can, in MATLAB, in one line, get the solution for this problem. So let's just go and define these matrices. Once again, clear the workspace, shrink this so that I can see both. So I'm going to define a variable called A. Capital A is equal to, I already know how to do this, 3, 7, minus 8. The second one is 6, 1, 3. The third one is minus 1, 4, 2. Okay. So I define a matrix and I define a vector. The vector is 16, 34, 25. It's a column vector, right? 16, 34, 25. So B is equal to 16, 24, 35. Notice how I'm using the semicolon. Okay, 16, first row is done. I'm not doing the second row, 24, and the third row, 35. So it will produce a column vector, 16, 24, 35, right? And to produce X, all I need to do is A backslash B. Okay. And it produces what? 3 numbers. The first number is for the lowercase x, the second number is for lowercase y, and the third number is for lowercase z. Okay, and in one of the labs you will go through a similar exercise on representing a given problem in matrix notation and solving it. Now, how do I know that this is the correct solution? Because A times x minus b should be equal to 0, right? Because I'm saying ax equal to b, and x is the unknown vector, and that vector contains this lowercase x, y, and z. Okay, so when I do this, I should get, predict, I should get 0. Do I get 0? Yes, that means the problem is solved, right? The x is the correct set of numbers for this equation that sets ax equal to b. Okay. I think I've taken more than an hour, so let me pause here, and I will come back next Monday. I'll come back this Friday, in fact, about Rose. So next Monday's lecture I'll be in person, and I will continue from this point on. This week you have the first lab on Wednesday and Thursday, but you are required to attend only one of them, the one in which you are registered. But if you have some issues on a particular day, and if you want to attend the alternate lab, you are welcome to do that. And you will be given a set of worksheets in the first few assignments, labs, so that you get to practice what we have seen in the class. And there might be a quiz, and this week maybe there is no quiz. But next week I will start conducting the quizzes. The quizzes will be based on what you do in the lab worksheets as well as what we did in the lectures. So I will construct a fairly large set of problems for you with worksheets. Execute every command in the worksheet. Make sure you understand that. Okay. Jillian will be there in the lab both on Wednesdays and Thursdays. And also I think I will ask the TA to be there so that you know where the TA is. And I've also asked the TA to set up an office hour for you every week so that if you have questions, depending on your schedule, you may not be able to come to my office hours, but you'll be able to go to his office hours. So we will kind of stagger it so that you have access on more than one day a week for office hour access for this course. Okay, so let me stop the recording there with lecture 2.